Hi guys, I know this question isn't in your packet, but I just want to make sure we understand it, so I'm going to put it as the first question. So in this question we have the length of a rectangle is 1 unit more than the width, and the area of the rectangle is 20. And we're trying to find out what is the length of that rectangle. So on the left, we're just going to write everything that we know. We know that the width is the last thing stated, so our width is equal to x. We know that our length is going to be 1 more than the width, so x plus 1. Remember, whenever we see more than, less than, or subtracted from, we have to switch the order. And we know that our area is going to be 20 units. From here, we're going to write down the area formula for a rectangle. Area equals length times width. We're going to take what we have on the left and substitute into this formula, area equals length times width. So our area is 20. Our length is equal to x plus 1. And our width is going to be x. Remember, our length, x plus 1, is more than one term, so we need parentheses around it. From here, I'm going to bring down the 20. And with this x on the outside, we have to distribute to the x and that positive 1. So x times x is x squared. And then x times 1 is going to be a 1x. Now I should see that I have an exponent of 2 right here, which means I have a quadratic. And in order to solve a quadratic, I need it to be set equal to 0. So I'm going to subtract that 20 over. Now I have x squared plus x minus 20 equals 0. From here, I should notice that we have a 1 a.m. problem. So I want two numbers that multiply to negative 20 and add up to a positive 1. So I should think of 5 and negative 4. Since it's 1 a.m., I'm just going to take my two factor bubbles, put an x and an x, and these numbers right here, that 5 and negative 4, just go right on the inside. So after I have a quadratic set equal to 0 and I factor, I have to set each factor equal to 0. So I have x plus 5 equals 0, x minus 4 equals 0. On the left, to isolate the variable, we subtract 5 and get x equals negative 5. On the right, we do the same thing and get x equals 4. Now let's think about this problem. It's talking about a length and a width. So with the x equals negative 5, we actually can't have that because we can't have negative length or a negative width. So we're going to reject that. Our x value is 4. So we're going to go back to our legend and we're going to plug in what we know. Our width is equal to x, which is equal to 4, but the question states find the length. So the length is equal to x plus 1, so 4 plus 1 is 5. So for this problem, we should have 5 as our answer. We could use the word problem to check. So it says the length is 1 more than the width. We know the width is 4 and the length is 1 more, so 4 plus 1 is 5. But then it also says the area of the rectangle is 20. So if we check it and see that 4 times 5 is 20, we know that we did it correctly. Okay, so now let's look at the actual packet. So question 1 says, which equation has the same solutions as 2x squared plus x minus 3 equals 0? From here, we should see that we have a leading coefficient greater than 1. So this is going to be a grouping problem. We take 2 times negative 3 to get our negative 6, and we want two numbers that multiply to negative 6 but add up to a positive 1. So we should be thinking 3 and negative 2. Once we have those two numbers, we're going to take our 2x squared and our negative 3 and bring them down, kind of like what we did right here. Then what we want to do is take these two numbers and put an x with them on the in-between. So 2x squared minus 2x plus 3x minus 3. From here, split down the middle and pull out the GCF. The GCF between 2x squared and 2x is a 2x. So when we take out or just divide out by 2x, we're left over with an x minus 1. On the right-hand side, the GCF between 3x and a negative 3 is a 3. So when we divide out by our GCF, we're left over with an x minus 1. We should notice that x minus 1 is the same. So we rewrite that once. Left over on the outside is a 2x and a positive 3, so that's our other factor bubble. For this question, we don't actually have to solve. We're just factoring for here. We're trying to come up with an equivalent equation. So we're just going to factor by grouping. For number 2, what is the solution set of the equation x squared minus 2x minus 8 equals 0? Again, we have a quadratic because it's raised to the second power. So once we see a quadratic raised to the second power, we need to make sure it's set equal to 0, which it is. From here, we're trying to decide which type of factoring. I have a leading coefficient of 1, and it is a trinomial, so it's going to be a 1 AM problem. I want numbers that add up to negative 2, but multiply to negative 8. So two numbers that multiply to negative 8 are negative 4 and a positive 2. So once I have those numbers, I put them in my factor bubbles. And then from here, since I am solving, I have to set each factor equal to 0, so I have to tee it off. So I have x minus 4 equals 0, x plus 2 equals 0. From here, I'm just solving an equation to get x equals 4 and to get x equals negative 2. So that's choice number 1. So in order to check to see if we did that correctly, what we can do is go to our calculator and hit the y equals button. From here, in y1, I want to put in the original equation, which is x squared minus 2x minus 8. So our goal, when we're looking for a 0 or a root or an x-intercept, or just solving a quadratic, is to find what x-coordinate would make that parabola hit the x-axis. So we're looking for when y is equal to 0. So when I look at my table, I should see negative 2 comma 0, and I should see 4 comma 0. So I know my roots have to be when x equals negative 2 and when x equals 4, because that's when y is equal to 0. Number 3 says, find the zeros of the following function. 81 x squared equals 4. So if given 81 x squared equals 4, our first step has to be taking that quadratic and setting it equal to 0. So we're going to subtract 4 to the other side to get 81 x squared minus 4 equals 0. That's how we got that first step. So once we have 81 x squared minus 4 equals 0, we need to make sure we know which type of factoring it is. Look for a GCF. If you don't see any and you see that it's two terms and both are perfect squares, you're going to set up two factor bubbles with a plus sign and a minus sign. From here, you want to take the square root of 81 x squared and place that number in front of the signs. So you're going to get 9x and a 9x, and then do the same thing for 4. So the square root of 4 is 2. 9x plus 2, 9x minus 2. From here, after you factor, you have to set each factor equal to 0. So when you tee it off, you have 9x plus 2 equals 0 on the left, and on the right, you're going to have 9x minus 2 equals 0. So in order to solve 9x plus 2 equals 0, you need to isolate the variable by subtracting 2. So you get 9x equals negative 2, and then divide by 9. So x equals negative 2 over 9. Same thing on the right-hand side. You want to add 2 over, then divide by 9, and you're going to get x equals 2 over 9. 4 says, given the equation x minus 2 times x plus 7 equals negative 20, determine all roots algebraically. So over here, where we have x minus 2, x plus 7, we should know it's a binomial times a binomial, which means we have to double distribute, or you could use the table method. So x times x is x squared, x times 7 is 7x. Then we go back to the negative 2. So negative 2 times x is negative 2, and negative 2 times 7 is negative 14. From here, combine like terms to get x squared plus 5x minus 14. I'm going to replace my left-hand side of the equal sign with an x squared plus 5x minus 14 and bring down my equals negative 20. Remember, you need the quadratic to be set equal to 0, so we're going to add over 20 to the other side. And we'll have x squared plus 5x plus 6 equals 0. From here, we should notice we have a trinomial with a leading coefficient of 1. So we want numbers that multiply to 6 and add up to 5 since it is a 1 a.m. problem. So two numbers that multiply to 6 and add up to 5 is a positive 3 and a positive 2. From here, we're just going to set up our factor bubbles, throw in an x and an x, and put the positive 3 and positive 2. Once we do that, we have to set each factor equal to 0. So we have x plus 3 equals 0, and then x plus 2 equals 0. From here, you're just solving a one-step equation, so subtract 3 to the other side to get x equals negative 3. And then here, we're subtracting 2 to the other side to get x equals negative 2. So for question number 5, we have 2x squared plus 3x minus 2 equals 0. From here, we should see that our leading coefficient is greater than 1, so it is not a 1 a.m. problem, but rather a grouping problem. So we're going to take the 2 and the negative 2 and multiply them together to get negative 4. We want two numbers that multiply to negative 4, but add up to a positive 3. So we should be thinking positive 4 and negative 1. From here, what we want to do is take our two numbers that we circled and bring it down. So our 2x squared and our negative 2 equals 0. Bring that down. And these two numbers right here, that 4 and negative 1, we're really going to break our 3x into those two numbers. So we have a plus 4x, a minus 1x. Once we have our four terms, we want to split down the middle and pull out a GCF on the left-hand side. We should notice that 2x goes into both 2x squared and 4x. So when I pull out the GCF, I'm trying to figure out what numbers go on the inside. So 2x goes into 2x squared with an x left over, and then 2x goes into 4x twice. On the other side, we have a negative 1 and a negative 2. From here, we should notice that our GCF is a negative 1, so when I divide both terms out by a negative 1, inside the parentheses, I'm left over with an x plus 2. We should notice that inside the parentheses, we have the same factor, so we're going to bring that down as one factor, x plus 2. On the outside of the parentheses, that 2x and that negative 1, that's our other factor. From here, once we factored, we set each factor equal to 0. So we have 2x minus 1 equals 0, and then x plus 2 equals 0. On the right, we're going to subtract the 2, and we have x equals negative 2. On the left-hand side, we want to solve for x. So add 1 to both sides to get 2x equals 1, and then divide by 2, and we get x equals 1 over 2. Okay, so for number 6, it says find the zeros of the function x to the third power plus 4x squared equals 21x. Remember, in order to solve, we need it set equal to 0. So we're going to subtract that 21x over to the other side. So now we have x to the third power plus 4x squared minus 21x equals 0. But we should see a problem. We don't really know how to solve anything to the third power. So what we should be looking for, like always, is a GCF. We should notice that there's an x in every single term, so we could pull out that GCF of x and put it on the outside. Inside the parentheses, we have an x squared plus 4x minus 21 because we divided out that x to every single term. So now left over in the parentheses, we have a 1 a.m. problem. So we want two numbers that multiply to negative 21 but add up to the 4. So we have a positive 7 and a negative 3. Remember, we have to bring down our x because that's still a factor. From the inside of the parentheses, we have that 1 a.m. So we're going to put an x and an x, and our two numbers that multiply to negative 21 but added to 4. So a positive 7 and a negative 3. Like always, we set every single factor equal to 0. So our first one, x equals 0, that's already solved for. In the middle, we have x plus 7 equals 0. So when I subtract 7 over, we get x equals negative 7. And then on the right, when I add 3 over, I get x equals 3. So we should remember that anything raised to the third power is a cubic function. And then the question says, How can this function have 3 roots or zeros? Remember, the